copying and comparing structure variables. So you can assign a structure variable name to another structure variable name, that is legal in case of C. Similarly, another example is also given here, person1, that is another structure variable name that is assigned to person2. So you can assign structure variables that is allowed or that is legal, but comparison of two structure variables is not allowed in C. Similarly, you cannot do like something like this, person2 not equal to person1. So these two are comparison statements, whether they are equal or not equal to. So relational operations and logical operations are not allowed with structure variables, but you can do it in structure elements. So here one example is given, student.number. Number is a structure element, so you are comparing that with another structure variable. So you can use this in compare statements. That is possible and that is legal. So you can compare only structure elements, not structure variables as such. Next topic is word boundaries and Slack bytes in structures. So to store any type of data in a structure, there is a minimum fixed byte reserved by memory. So that is called a word boundary. So that is, word boundary is nothing but minimum fixed byte reserved by memory in order to store any type of data. And this word boundary is machine dependent. And when you are storing elements in memory, structure elements in memory like this, always it is left aligned. So for example, if my structure has two elements, one is a character, another one is int, and if the word boundary is 2 bytes, then the first character will be stored the first location, and second one will be left as such. This is called the Slack byte, because the minimum space for storing a structure element is 2 bytes. So here we are using 1 byte for storing the character, the other byte is left behind, that is called the Slack byte, and then the 2 byte is used for storing the next integer. So the fixed minimum byte reserved by memory is called word boundary, and this is how it is done. So you can see that the data stored in this Slack byte will be some random number, or you can say it is undefined. So you cannot compare two structures directly, because the data stored in those two structures in this Slack byte area will be different. So you cannot compare two structures due to this. Now let's see the operations that can be done on individual members of structure. A member of a structure can be considered as any other variables in C, like integer variable, float variable. You can consider member of a structure similarly. Okay, so you can manipulate the member of a structure using expressions and operators in C. Okay, for example, you can see how it is manipulated here in this expression. If student1 dot number, so number is an element, and if that value is equal to 111, then the marks element should be equal to marks element plus 10. Okay, and float sum is a float variable, which is equal to student1 marks. Marks is another element of the structure student1 plus the marks of structure student2 can be added and stored in the float variable sum. Similarly, this one also can be done. So what you can see here is you can manipulate the structure members using the expressions and operators that are available in C. There are 3 ways of accessing members of the structure. So let's see which are the 3 ways. So struct vector, int x and y are 2 elements of this structure, and I have declared 2 variables here. One variable v I have declared, as a vector. So this is a structure variable and this is a pointer to a structure vector. Okay, so pointer you haven't learned about it so far. You will be learning about it in the next few classes. So for the time being, you just need to know how you can access member using a pointer. So pointers normally are used to indirectly access data from memory. Okay, so here in this pointers are defined using an asterisk. You can see here an asterisk is used here along with the variable name ptr. So this is a pointer variable and ptr holds the address of the structure v. Okay. So these are the three methods of accessing members, say member x of the structure vector. So our structure is called v, and how can you access the member x of the structure? The first method is using the vector variable name v dot x. So you can access this of the variable v using this notation. This is called dot notation. Another method is using the pointer. So star ptr or asterisk ptr within brackets dot x. This is called indirection notation. And the third is using the pointer itself. So here you need not use the asterisk symbol. Directly you can write the pointer variable name and the arrow operator and the element name. So you can see three methods are there to access members. First is called the dot notation, second is indirection notation, and the third is selection notation. Okay, so you will be learning more about pointers in the classes that are following. Now let's see array of structure. So we have seen how you can define an array, how you can declare array variable, structure variable, and how you can access elements of a structure. Now let's see how you can define an array of structures. So here one example is written, struct class student. So till this part you are familiar. So normally whenever you declare any array, structure variable, you have to use the keyword struct, then the structure tag name class, and then the variable name student. So here you can see one more term is added here, that is for the array. So student is not just a variable, it is a array variable. Okay, so what is an array? It holds similar type of data. So here what is that data stored? Structure. So there will be 100 structures of type class stored in the student array. Okay, so the index will start from 0 to 99. So in each position, so you can see this is an example I have written here, struct marks, then in subject 1, subject 2 and subject 3. Okay, so I have defined the structure, and in main I have declared an array of the structure marks, and the name of that variable is student. So I am assigning values to this array. So here the number of or size of the array is 3. That means the index starts with 0, 1 and 2. These are the 3 indices of this array. So in first location, subject 1 mark will be 45, 68 and 81. So for student 0, subject 1 mark is 45, subject 2 is 68 and subject 3 is 81. For student 1 it will be 75, 63 and 53, and for student 2 it will be 57, 36 and 71. Now how do you access elements from an array of structures? So we'll take the same previous example here. So if you want to access 45, what is the array location? Array location is student 0. Student 0. So student 0. So 3 marks of that student is written here, subject 1, subject 2 and subject 3. So since you are accessing the first element, so that is student 0 dot subject 1. If you want to access 68, student 0 dot subject should I write? It will be student1 dot subject 2. Subject 2. Okay. So similarly, you can access any element. Now, array within structures. So earlier we saw array of structures. So this is array within a structure. So this is a structure, tag name marks and the variable name student. This is also an array. This is the array of structures. So we have two structures stored in this array, and that structure, each structure will have two elements. One is a number, integer, and the other is a subject, float. But again, this subject is also an array. So this subject has three terms are coming here: subject 0, subject 1, and subject 2. So three subject data is stored in this one array. Okay, so that is why it's called array within structure. So this is the structure, and there is an array within this structure. So how do you access this subject? So here one example is given. If I want to access the mark of first subject of first student, I have to write student 0. So the students, you have stored the marks of two students. Okay, two students. So the first student's marks will be stored in student 0, and the second one will be in student 1. So I want to access the mark of first student. So that is student 0. Student 0 dot which variable, which element you want to access? Subject 1. So student 0 dot subject 1. Okay, so you are using the name of the structure, the outer structure, and then the name of the inner structure and the element index you are using. Structures within structures. Nesting structures are also there in C. Nesting structures. So I have taken this as an example. This is a normal structure named salary with these elements and the variable employee. You can see here three allowances are coming here. I am going to convert, or I am going to create a new structure within this one, and these three elements will be part of that substructure. Okay, so character name, department, basic pay will be there as such, and then these three elements will be put into another structure. So let's see how you can do that. So here struct salary, character name, department, basic pay. Then I have written another structure. So without any tag name I have written it, and the variable name allowance, and the dearness, house rent and city I included in this structure. So this structure is coming within another structure. That's why it's called structure within structure. Okay. So if you want to access house rent, that is a part of this allowance, how do you access that? So you have to start from the outer structure, that is employee, outer structure variable. So employee dot allowance, then the inner structure name allowance dot house rent. Okay, so that is written here, employee dot allowance dot house rent. If I want to access city, then again outer structure variable employee dot allowance dot city. So this is how you access elements of a structure that is within another structure. Similarly, you can have an inner structure with multiple variables also. In the previous example, we saw only one variable. Here I am using two variables, allowance and arrears. And if you want to access the element of arrear, how will you do that? These both are variables of this particular structure. And if I want to access the element of arrear, that is house rent. So both these variables have three elements: dearness, house rent and city. I want to access the element house rent of arrear. How will I access it? So again, outer structure variable name employee. Since this is an array, you should know the index number. So if you want to check the arrears of the first employee, then the index should be employee 0. Okay, employee 0 dot arrears dot house rent. Okay. If you want to know the city of employee 0, then employee 0 dot arrears dot city. Okay. So that is how you access the elements of inner structure. So you can also give tag names to define inner structure like this. So here this is an inner structure. So in this structure, this is struct salary. Within this structure, another structure is also there, pay allowance. This pay is a structure. This allowance is a structure of type pay that is defined here. Okay. So pay is struct pay. It has 3 elements. Okay, and then struct salary as again 4 elements. Out of these 4 elements, 2 are elements of type pay. Okay, so you can declare an employee variable of type salary, and you can declare it as an array also. So if you want to access it, like in the previous case, you can access the elements of any structure that is within another structure. So nesting more than one type of structure is also possible. That is, this is your main structure. Within that structure, you can see structures with different elements. So this structure, variable name is name and the tag name is name part. It has got different number of different types of elements. This one has got another type of elements. This another different types of elements. So you are grouping different structures which are having different types of elements in one structure personal record, and you can declare a variable of type personal record like the struct, the tag name of that particular structure, and a variable name. So this is how you can define a structure that is nested. Now let's see a few examples based on structures. So the first one is, you can just look here, you can see how you can access and print the element data. Okay, so here hash include stdio.h, struct point is the tag name of my structure, and it has got 2 variables, int x and y, and then I've closed it with braces and semicolon. Now void main, open brace, then I am declaring a variable p1 of type structure point, and also I am initializing the value of those elements. Okay, so struct point p1 is the variable name I have given, which is equal to, this is how you initialize the elements. So using open brace and close brace, there are 2 variables here, both are of type int, so I am giving 2 integer value, putting a comma in between, 0, 1, open brace, close brace, and a semicolon. So you should be careful with these syntax, how you can declare, how you can initialize. So you should be very careful while doing this. Don't leave any of these operators that I used here. Don't leave any of these or brackets. Don't forget to do that. Then p1.1 dot x. What is p1? P1 is the variable name. p1 dot x. So this variable is of type struct. So that means this p1 has 2 integer values, x and y. So in that, x should be, as x is assigned 20. Okay. Initially it was 0 and 1. Initially x value was 0. Then I am changing it to 20. Then I am printing at printf x is equal to %d, y is equal to %d, and p1.x, p1.5. Since I changed the value of p1.x to 20, it will print 20, and p1.y I didn't change, so it is 1. Okay. Another example here, stdio.h struct point in x and y, void main. So here I have defined an array of size 10 of type point. Okay, so the first element of the array 0 dot h. So array 0 will have 2 values, x and y. So array 0 x value is 10, array 0 y value is 20, and I am printing those values array 0 dot x, array 0 dot y. Output will be 10 and 20. So similarly you can print array 0 to array 9. So 10 different array locations are there, array indices are there, and in each index you will be storing different x and y values. So this is how you can access data from an array. So that's all about the structures. With that, I'm concluding the topic structure, but you have to go through more programs, and you should make yourself familiar with handling structures, how to define a structure, how to declare a structure, how to manipulate data within the structure. So such things you should become thorough. In order to do that, you should do a lot of programs. I have included assignment questions based on structures. You should complete that, and you should submit the assignment